Hello everyone and welcome to your Chem 113 review on electromagnetic radiation. My name is Jason and I work for the ASU Tutoring Centers. So we are trying to organize these different types of electromagnetic radiation based on their frequency. What is frequency? Well, frequency is defined as the number of complete wavelengths that pass through a given point each second. So what exactly is a wavelength though? So a wavelength, so imagine you have a wave. And this is very common to do because light, which is essentially what electromagnetic radiation is, it's like different forms of light energy. Light acts as both a particle at times, but also as a wave. So when we're thinking about electromagnetic radiation, we think about the wave properties of light. So wavelength is the distance between two peaks of a wave. That length right there, that's the wavelength. You can also think of it as the distance between two troughs, to the bottom parts of the wave, but that should be the same distance. So they often commonly think about wavelength as being between the tops of waves. That's wavelength. So frequency is just the number of complete wavelengths that pass through a given point each second. So if you imagine you have a wave. So let's say this is the point we're looking at. And imagine you have a wave that looks like this. So it's pretty like tight together, right? Then as this wave moves through this point, in 1 second, you might have like this wave, this wave, this wave, this wave, this wave, and that wave. Maybe those 6 pieces of the wave pass through that one point. Whereas if you were to have, say, a wave that looked more like this, in the same time, maybe only these 2 peaks pass through this one point that we're given. Because they're longer spaced apart, so it's going to take more time to get between each peak of the wave. So there's sort of this inverse proportionality between frequency and wavelength. As you increase wavelength, as the waves get further apart, it takes more time to travel from the top of one wave to another. So increased wavelength leads to decreased frequency. And the same goes, vice versa. Okay, so that's frequency and wavelength in general. Now we're going to try to organize these different types of electromagnetic radiation based on their frequency. And that's a tricky thing to do. What I often do when I think about this is I think in terms of how much damage would these different types of waves do to a person. So visible light, that's sort of like the middle ground, okay, visible. And we're going from smallest frequency to largest, okay? So visible light, that's the middle ground. And then we build on the rest of our different types of radiation based on how much damage they will do to us. So if I'm looking for the most damaging rays, so just think in terms of real life. Ultraviolet rays can be pretty damaging, right? Those are the rays that come from the sun. They can heat up your body. They can, cause skin cancer. Ultraviolet rays can be very damaging. Similarly, X-rays, those are very damaging, right? We go and get those at, say you go to like a dentist and they take an X-ray of your mouth. We have to have those giant lead aprons on so that we don't get X-rays going through our whole body, because having that over and over and over again can be very dangerous. And then gamma rays are also incredibly dangerous, right? I mean, they turned Bruce Banner into the Hulk. They must be pretty dangerous. But yeah, no, gamma rays are notoriously, if you get a bunch of gamma rays through your body frequently, that's not going to be good for your health. So I think of these as being particularly damaging rays. And why are they so damaging is because they're high frequency. So they look like this, the waves. They're really close together. So you can almost think about it as like, if you're imagining your body and a wave like this is hitting it, it's hitting it over and over and over and over and over and over and over again. It's like you're getting like speed punched by a boxer and just going into you. So there's sort of this occurrence, this coincidence between a high frequency and most damage done to your body. Because as the frequency increases, the way I visualize it in my head as like you're getting hit a lot more with the wave, okay? So when you're trying to remember which of these waves has the higher frequency, it all depends on how damaging it is. Now, of these three, ultraviolet rays are certainly the least damaging to us. We see that all the time. We're constantly being hit by ultraviolet rays out in, just when we're walking through the sun. So ultraviolet rays are on the more frequency side, but they're not the most, right? So they're just going to go next. Next one up would be X-rays, because again, we do come into X-rays in our day-to-day lives, at least way more frequently than we come into gamma rays. They're still not necessarily good for you, but we have them all the time when in the case of like medical X-rays. And then gamma rays would be the most damaging. So these are organized that way. And now we work the other way around, okay? So we're still thinking in terms of damage. These don't really damage us too much. IR, radio frequency, and microwaves. But the way that they would be organized, the most damaging of these three is infrared radiation. And then it's microwaves. Because you have your microwave, and you're constantly told not to stand too close to the microwave, right? It can be bad for you. It certainly won't be as bad as like UV radiation, but it still can do some damage. And then the smallest amount of damage done is radio waves. We are constantly surrounded by radio waves, being bombarded by them, just in terms of like TV signaling, in terms of radio signaling, just nonstop radio waves are flying through the air as we speak. So radio waves are certainly the least damaging. We're constantly being surrounded by them. So these are the 7 major types of electromagnetic radiation, organized from smallest frequency to largest frequency. And again, the way that I personally remember it is organizing it in terms of least damaging to a human up to most damaging to a human. Okay? So that's your little fun fact for the day. All right. Well, thank you for watching. If you want more information about the free tutoring services available on all 4 major ASU campuses and online, please check out tutoring.asu.edu/content/tutor-search. If you go here, you'll be able to find a tutor on your campus or online, and that will help you with your specific course. Thank you again for watching, and I hope you have a wonderful day.